Hi guys, in this video we're going to have a look at sketching different types of graphs, including straight lines, parabolas, these quadratic graphs at the bottom, and these really squiggly ones called cubic graphs. So let's start with the linear ones. So we should know already that we can express the equation of any straight line using this formula y equals mx plus c. And this bit here, the m, tells us the gradient, so whether it's going like this in this direction, be a positive gradient like y equals 2x or 3x or 4x, or we can have it coming down in a negative direction, which would be minus 3x, for example. And this constant term on its own, a number, that would be where it crosses our y-intercept. So for example, the graph y equals 2x plus 1, that would cross our y-axis at 1 and going in a positive direction. So it's a pretty, see if I can just move that down a bit, because that's pretty shocking. No, it won't let me. But that was meant to go through that line. And let's just try another one. So if we had something like y equals 4 minus 3x, well, that's going to cross at 4, so let's say up there. Because it's a minus 3, it's going to come down in this direction, like so. That's a better one. And basically, the bigger this number is here, the bigger this coefficient of x, the steeper the graph will be. Now when I say bigger, it's important not to get confused with the negatives. The 3, let's say y equals 3x plus 2. Although technically 3 is a bigger number than minus 3, these are what we have, say, the same steepness, the same gradient. The negative here just tells us it's changing its direction. So the negative and the plus, or the plus, it tells us its direction, but the coefficient of x tells us the gradient. Okay, that's pretty simple, you should know that already. Now, quadratic graphs, we write these in this form. And it's really handy because on both of these we had this part, the plus c, and which means exactly the same thing. It's where our graph crosses the y-axis. It's the same. Now you'll notice that I've no longer got a straight line. As soon as we have this quadratic, our graph is either going to be this way up or this way up. And the way we tell that is looking at the coefficient of the x squared. So if a is positive, so let's say a is more than 0, we can't have 0 because it would be a linear graph. And here, if a is less than 0, it's going to look like that. Now you can identify quadratics quite easily. They come in many different forms. Something like, this is an example, so this would be a basic one, just y equals x squared minus 9, or just y equals x squared. We could give it to you in its factorized form. Let's just do that one above. So that's exactly the same graph, just in its factorized form. It could be slightly more complicated, something like that. Or we can give it to you in another factorized form, just different to the second one, maybe the complete and the square. Something like that. So looking at all of these, I can tell you that these are quadratic graphs, and that's purely because there's a squared. This one there hasn't, but x times x would give me x squared. So that's how you tell a quadratic graph. Now, you can notice that all these x squareds were positive, so they're all like this one here. So for this inverted parabola, like this N shape, you're looking for things like this, so minus x squared plus 4. We could have like something like this, minus x plus 2. I think you get the gist of it. So you're looking for something that gives you a negative x squared, and it's going to be like that. I'll just chuck one more one for good measure. Something like that. Okay, let's go on to the cubic graph. So it's really important you can identify the different types. Now, cubic graphs they just get a bit more bendy basically. So what they normally look like is something, there you go, that's not bad. So y equals x cubed could look like that. So this is what you're looking for to get this sort of shape. Now the ones that you're going to be sketching in the lesson, they're going to go more so like this. We're going to be finding out roots of these, and we're finding out the y-intercept to help us sketch these graphs. So this is what you're going to be learning in C1. Now these graphs, obviously it can look like this, y equals x cubed, or y equals 3x cubed minus 3x cubed, something like that. Even putting a bit more on, this is all going to be graphs that resemble this picture. We could give it you in its factorized form, so something like this. And don't worry if you're watching this, go, I don't know how to factorize like this. You will do soon. And sometimes this confuses people. This is exactly the same as the one above, but here there's just an x on its own. If you like, it's x plus 0, but we don't bother writing that because we're better mathematicians than that. So anything with a cubic, so here we'd have a cubic from that, and likewise here. It would always resemble this type of graph. Now if it was, let's just draw another one of those. Oops, that's a bit rubbish. You'll notice the cubic graphs went in sort of this direction. I'm just going to write, that's not x cubed, but it's just to resemble the direction. Now if we had a minus, what actually happens is it's reflected just like the parabolas here. So you can see it's reflected. If I draw an axis, you'd see it's reflected in the x-axis. So this is going to do exactly the same. So instead of starting at the bottom left, we're going to start at the top left, and you would get something like that. So anything with a minus with an x cubed is going to turn it upside down. So that's all I want you to kind of understand. You need to be able to look at equations and identify whether it's like this or like that. So positive or negative with just an x. This one, it's going to be x squared or minus x squared. And these ones, a bit more squiggly, would be x cubed or minus x cubed. So bring this knowledge to the lesson and you'll be absolutely brilliant. Okay, good luck.